The fourth topic for this chapter is bus interconnection. We learned before this that in our computer there are several components. For example, the CPU, memory, and input-output module. And these components basically are interconnected to one and another. There must be a mechanism on how to connect these components. And the mechanism, we can call it as a system bus. A bus is a communication pathway connecting two or more devices. A key characteristic of a bus is that it is a shared transmission medium. Multiple devices connect to the bus, and a signal transmitted by any one device is available for reception by all other devices attached to the bus. If two devices transmit during the same time period, their signals will overlap and become garbled. Thus, only one device at a time can successfully transmit. Typically, a bus consists of multiple communication pathways or lines. Each line is capable of transmitting signals representing binary 1 and binary 0. Over time, a sequence of binary digits can be transmitted across a single line. Taken together, several lines of a bus can be used to transmit binary digits simultaneously. Computer systems contain a number of different buses that provide pathways between components at various levels of the computer system hierarchy. A bus that connects a major computer components, for example, processor, memory, and input-output, is also known as a system bus. The most common computer interconnection structures are based on the use of one or more system buses. This is the bus interconnection scheme. So we have different modules here, which is the CPU, memory, and input-output. And these modules are connected with the system bus. The system bus consists of the control lines, address lines, and data lines. We know that system bus consists of data lines, address lines, and control lines. Basically, the data bus is a collective of data lines. Data lines provide a path for moving data among system modules. The data line may consist of 32, 64, 128, or more separate lines. The number of lines is referred to as the width of the data bus. The number of lines determines how many bits can be transferred at a time. The width of the data bus is a key factor in determining overall system performance. We know that system bus consists of data lines, address lines, and control lines. Data bus is a collective of data lines. Data lines provide a path for moving data among system modules. Data bus may consist of 32, 64, 128, or more separate lines. The number of lines is referred to as the width of the data bus. The number of lines determines how many bits can be transferred at a time. The width of the data bus is a key factor in determining overall system performance. The address lines are used to designate the source or destination of the data on the data bus. If the processor wishes to read a word of data from memory, it puts the address of the desired word on the address lines. The width of address bus determines the maximum possible memory capacity of the system. Furthermore, the address lines are generally also used to address input-output ports. Typically, the higher order bits are used to select a particular module on the bus, and the lower order bits select a memory location or input-output port within the module. Control lines are used to control the access and the use of the data and address lines. Because the data and address lines are shared by all components, there must be means of controlling their use. The control signals transmit both command and timing information among system modules. The timing signals indicate the validity of data and address information. The command signals specify the operations to be performed.